All right, hello, pre-algebra students. Today we are going to look at lesson 1-7, which is the last section of chapter 1. Very quick, short chapter of scatter plots. Okay, today our objectives are just going to be to interpret scatter plots or to interpret what we think would be the relationship between two different measures of data. All right. Key term is scatter plot, graph that shows the relationship between two sets of data. The data is represented as an ordered pair, which, if you remember back from 1-6 yesterday, we talked about an x value and a y value. And a lot of times these will represent, for example, maybe distance, right? And y would be time. Could be any two sets of data. And we plot those on a coordinate plane. We're not necessarily going to be looking at the plots as much as we are just interpreting what's going on. So there are three types of relationships, or correlations is another word that's often used to describe it. The first one is positive relationship or positive correlation, and that's when x increases, y increases. So if we look here at the plotted points, we can see that this data, well, it's not linear in a straight line, it's trending in the positive direction, right? It kind of jumps around a little bit, but overall it's trending up. That would be a positive relationship. A negative relationship is like this graph here, or negative correlation is another way to say that. And it's when x increases. So as I move to the right, these x values are increasing. Notice the y values are trending downwards. That is a negative relationship or a negative correlation. And the last one is no relationship or no correlation. There's no obvious pattern. The dots are kind of just random all over there. There's really no trend in the positive or the negative. So that would be no relationship. So here we're going to look at some situations and talk about whether it's might show a positive, negative, or no relationship. So in number one, we're looking at the size of the household and the grocery bill. So for example, if I have a household of one, when I go to buy groceries, I only have to buy for one person. If I have a household of two, right, obviously I'm buying for two people, and the grocery bill is going to go up because you got to feed two mouths, right? Get up into family of five, and your grocery bill is going to increase even more because you're feeding five people. So that would have a positive correlation or positive relationship, meaning that the as size of household goes up or increases, grocery bill will also increase. So that's a positive correlation. The month you were born and birth weight. Okay. So the month you were born and birth weight. So if I'm born in January, would that give me a higher birth rate than if I was born in February or March? And if you think about it, baby's weight does vary, right? You have some lighter babies, 6-7 pounds. You have some heavier ones, 12, 13. But the month and birth weight has no correlation. You could weigh 12 pounds in January. You could weigh 12 pounds in December, right? There's no correlation there. The size of a shirt and its cost, right? Think about going to a store and you look on a rack, you have your small, your medium, and your large. Typically, those are same price for any of the shirts, whether you get a small, a medium, a large, extra large. So really, there's no correlation there. Now, you could argue that, youth sizes are typically cheaper than adult sizes. So if you put positive there, that's probably, you could argue that situation. And look here, it says scatter plot for the following data that it might show. So if your logic is saying, well, I'm comparing youth sizes to adult, you could probably get away with positive correlation there. And last one here, time spent on video games, right, which would obviously keep you indoors, versus time spent outside. So if you think about it, if I'm spending more time on video games, so if this is my X and this is my Y, right, let's say I spend 8 hours on, well, let's say I spend 1 hour on video games, right, that gives me more time to spend outside. Let's say we have 8 hours total, right? So let's just draw a little thing here. So this is my video games, and this is outside. So let's say I have 8 hours to spend, right? If I spend 1 on video games inside, that gives me 7 that I could spend outside, right? If I spend 2 inside, right, I could spend 6 outside, and so on. So the more time I spend on video games, right, the less time it gives me to spend outside. So there is a negative correlation there, right? And as I increase my time on video games, it decreases my time outside. So that would be a negative relationship there. All right, our practice for today is on page 42, numbers 4 and 5, 8 through 13, and 28 through 36. All right, hope everyone has a great day, and we'll talk to you soon.